Pleasant day, ladies, gentlemen, and variations thereupon. As part of our course subject History of Math, I, Clarice Valarca, together with my partner Kiana Ray Banyas, will discuss a very fascinating topic to you all, the First Awakening Fibonacci. Let us start with introducing the protagonist of today's discussion.
Fibonacci has a different names. He can also called as Leonardo Bonacci, Leonardo Pisa, Leonardo Fibonacci, Leonardo Pisano Bigolo. He is an Italian mathematician from the Republic of Pisa, revered as the most talented Western mathematician of the Middle Ages. He spent his life in contributing in mathematics, and he was born on 1170 in Pisa, Italy. He studied mathematics in Bugia, Algeria in North Africa. He died between 1240 to 1250, most likely in Pisa, but it was not clearly exactly stated where and when. Fibonacci published works are the Liber or the Book of Calculation. It was published on year 1202 and 1228. Second one is the Practica Geometria or the Practice of Geometry. It was published on year 1220. The third one is Liber Quadratorum, the Book of Square Numbers. It was published on year 1225. And he also popularized the Hindu-Arabic numeral system in the Western world through his book. So it will tackle this in the next slide. The Liber Abaci, also known as the Book of Abacus, the Book of Calculation, is a seminal mathematical work written by Leonardo of Pisa, commonly known as Fibonacci. So, the book was published in 1202 and is considered one of the most influential mathematical texts of the Middle Ages. In Liber Abaci, Fibonacci introduced the Hindu-Arabic numeral system to Europe, so including the use of 0 as a placeholder and the 10 digits we use today. The 1, 2, 3, 4, 5, 6 up until 9. Before the widespread adoption of this system, Europeans primarily used the Roman numeral system, which had limitation in performing complex calculation efficiently. His book Liber Abaci covers various topics related to arithmetic, algebra, and practical application of mathematics. It includes explanation of basic arithmetic operation, fractions, square roots, and method of solving problems related to commercial transaction, exchange rate, and other mathematical puzzles. Fibonacci's work in Liber Abaci was instrumental in promoting the adoption of the decimal numeral system in Europe, which significantly improved mathematical computation and revolutionized various fields such as commerce, science, and engineering. So the book had profound impact on the development of mathematics and played a crucial role in shaping modern arithmetic and algebraic practice. Fibonacci spent a significant part of his childhood with his father during his father's work-related travel. So his father's name was Guglielmo Bonacio, and he was a merchant from the city of Pisa, Italy. As a merchant, Guglielmo Bonacio would travel extensively for business, so visiting various trade centers and markets. During his travels, he would take young Leonardo along with him, so intending to expose him to the practical aspect of commerce and business. So this was a common practice in those times, where children from merchant families were often educated in the field of trade and commerce from a young age. So way back, his father wanted him to become a merchant also as him. So while accompanying his father, Fibonacci was exposed to diverse cultures, customs, and mathematical system used in different regions. So this exposure proved to be highly influential in his later mathematical pursuit. So this is the time he learned about various arithmetic and mathematical techniques employed by traders, so which is eventually inspired him to write his famous book Liber Abaci, so introducing the Hindu-Arabic numeral system to Europe. So his experience during his travel with his father provided him with a unique perspective on mathematics and arithmetic, so which is later applied and shared in his groundbreaking mathematical works his contribution to mathematics have left a lasting impact on the field, making him one of the most renowned mathematicians of the Middle Ages. Through his contribution in mathematics, and also his book Liber caught the attention of Holy Roman Emperor Frederick II, which was later the book of Liber Quadratorum is also dedicated to this emperor. So the Hindu-Arabic numeral. So as a young man, Fibonacci traveled widely in the countries of Mediterranean, observing and analyzing the arithmetical system used in the commerce of the different countries. So he quickly recognized the enormous advantage of the Hindu-Arabic decimal system with its positional notation and zero symbol over the clumsy Roman system still used in his own. So ito na nga, no, yung return niya sa Pisa in 1202, he wrote this book, Liber Abaci, so in which explained the virtues of the number system in order that the Latin race might no longer be division in that knowledge. So the first chapter opens with a sentence, there are the 9 figures of the Indians, 9, 8, 7, 6, 5, 4, 3, 2, 1. So with these 9 figures and with this sign 0, any number may be written. So it was included in the second edition of his work Liber Abaci, which appeared in 1228, that Christian Europe became acquainted with the Arabic numerals. Way back, nagkakagulo pa sila dito kung anong dapat ba gamitin. So yung that time na 1202, yung pinablish niya tong book na to, hindi pa siya ganong gamit. Kasi kung baga may iba-iba pa rin ginagamit yung mga Hindu. And later found out in 1228 na useful pala to, lalong-lalo na sa exchange rate, sa barter, yung ganun nga sa mga exchange ng goods. So yun sa trabaho ng tatay niya na merchant. Yun nga, no? Although Arabic numerals were not entirely new to Europe, so many mathematicians proposed this. So Fibonacci Liber Abaci showcased their superiority and contributed to their acceptance. So the origins of the Hindu-Arabic numerals are uncertain, but it likely originated in India. So reached Baghdad in the 8th century and eventually spread to Europe through Moorish Spain. So the evolution of number symbols. So written numbers symbols appeared in India before the dawn of the Christian era. One of the earliest preserved example is found in records cut on the walls of a cave in a hill, Cattled in Nanagat near Bombay, if correctly interpreted. So as you can see, no, yung through 3rd century BC, ito yung symbol na gamit nila sa number 1, 2, 4, 6, 7, 9. And also nag-evolve na siya noon, Brahmi, 2nd century. So ito na yung number symbol ng 1, 2, 3, 4, 5, 6, 7, 8, 9. So in Devanagari, 8th century naman, ito naman most likely nag-evolve na siya. So yung 3 parang siyang 2 na nadagdagan ng curve. And yung 4 nila is parang 8 natin ngayon. And next, West Arab Gobar, 10th century. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So ay na, unti-unti na siya nag-evolve. And sa Spain 976, ito yung number symbol nila. So ito way back nga to. Ito nga yung may conflict sila kasi lahat sila applicable sa pag-solve ng problem. Kaya nung that time yung Liber Abaci ni hindi siya gaanong ka-powerful or di pa siya gaanong accepted. Kasi nga nagko-cause siya ng confusion. Kasi nga marami kang pwedeng gamitin na number symbol.
Next up, we have the Liber Quadratorum. As mentioned earlier, Liber Quadratorum was published dedicated to Frederick II. This book was the product of all the collected theorems Fibonacci proved while exchanging letters with the scholars of Emperor Frederick II. Liber Quadratorum is translated as the Book of Squares. It is a systematically arranged collection of theorems, many invented by Fibonacci himself, who used his own proofs to work out general solutions. This was considered as Fibonacci's masterpiece and helped him revered as a major contributor to number theory together with Diophantus and Prieur de Fermat. This here are some of the theorems that are included in the Liber Quadratorum. I'll leave a link for a copy of the translated book if you would like to explore more. And of course, since we are talking about Fibonacci, we can't miss his most famous work, the Fibonacci sequence. The Fibonacci sequence is a series of numbers in which each Fibonacci number is the sum of the two preceding numbers. It was first introduced in his Liber Abaci book through a mathematical problem famously known as the rabbit problem. The problem reads as, a man put one adult pair of rabbits in a certain place entirely surrounded by a wall. How many pairs of rabbits can be produced from that pair in a year? If the nature of these rabbits is such that each pair begins to breed in the second month after its birth to produce one pair per month. On the basis that none of the rabbits die, starting with 2 adult rabbits, on the first month will bear 1 pair of young rabbits. Then on the second month bears another pair of young rabbits. Then on the third month bears another pair of young rabbits, plus the firstborns are now adult, which bears another pair of young rabbits. On the fourth month, the secondborns are now adults, making a total of 3 pairs of newborns, and so on. The point to remember is that each month the young pairs grow up and become adult pairs, making the new adult entry the previous one plus the previous young entry. Each of the pairs that was adult last month produces 1 young pair so that the new young entry is equal to the previous adult entry. Which, if you'll observe, the behavior of the numbers of pairs produced will give you an example of what we call now a Fibonacci numbers. That is, each term in the sequence after the second is the sum of the 2 that immediately preceded. What's fascinating about these numbers is that the ratio between the succeeding terms, although not concise, approaches the Euclid's ratio, a plus b is to a as to a is to b, or now known as the golden ratio. This here that is presented is also called as the Fibonacci spiral. Another fun fact is that the golden ratio is coined as a nature's code, as it appears in almost everywhere in the nature. Just as shown in the example, the sunflower heads, the snail shells, the arrangements of leaf buds in stem, even in the human body, the proportion of your face, your fingerprints, and so on, pine cones, hurricanes, and even the galaxy, the spirals in galaxy, means that the Fibonacci sequence exists and can be found in almost everywhere around us. And that concludes our presentation. Again, I am Clarice Falarca together with my partner Keanu Ray Banyas. Thank you for watching.